Hello there. Today we're going to talk about interviews in algorithms. Now, a question you should be asking yourself at this point in the course is, why have I taken algorithms? And there are a lot of potential answers to that question, including that computer science very much has at its heart algorithms, or perhaps that it makes you a better software engineer. But those aren't really the only reasons. There's a more practical one. And that's getting past a job interview. If you didn't already know, most companies aren't going to hire you just based on your resume alone. They're going to bring you in for an interview. Now, I like to think I'm a pretty smart guy, but I've never been through a whiteboard interview. I have given several whiteboard interviews, but that's not really the same thing. At the same time, I have never been hired by a company, although I have been hired by at least 2 universities. Finally, I've never worked in industry, so in some ways I'm wildly unqualified to talk about the interview process. On the other hand, I have talked to friends who have gone through the hiring process on both sides. So I do have some experience to share here, but you should take it all with a huge grain of salt. When you're being interviewed, the interviewer is trying to suss out a few different pieces of information. There's 3 primary questions. First of all, can you solve technical problems? That's more or less what a software engineer does, right? They're trying to figure out, if they give you a coding problem, can you figure it out? Can you also communicate your solution effectively? Communicate in order to gather requirements? Communication's very much also at the heart of what we do. This is not a single player game. We have to work together in order to accomplish things at scale. But then finally, they're also trying to figure out if you fit their company's culture, which is a pretty nebulous kind of phrasing to describe a very nebulous kind of idea. And there's not necessarily a way to prepare that beyond making yourself someone who is able to fit into a lot of different cultures. We'll talk a little bit more about that before we're done, but it's not necessarily the thing we'll focus on. Now, in order to assess these questions, there are several different general kinds of interviews that they'll use. We'll talk about conversational interviews, critical thinking interviews, the project architecture, and the whiteboard interview, but I'll point out that there are many other kinds. And in fact, given the current pandemic and the shift to remote interviews, we're probably going to see some different evolutions of these existing ideas. Again, you need to take everything I say with a grain of salt because I don't know what the world's going to be like. And in fact, no one really does. We're going to start with the conversational interview, which is, I think, one of the more interesting ones. The idea here is that you're just going to talk about things. Now it's a technical conversation. It's not going to be just how's the weather right now. It's going to be about coding and software engineering type of subjects. I recommend right now stopping this video, and you'll come back to it, but before you do, go and find someone and describe a software development project that you have been personally involved in, that you've written code for. This could be a school project, but ideally it isn't. Ideally, if you can, don't make it a school project, make it a real coding project that you've done for an internship or a research project or just a side project. You want to describe it using technical vocabulary. And it's surprising how difficult this is. If you've never practiced this skill, being able to go back and explain what you did and why it was interesting, it turns out it is a skill, just like anything else. And if you've never practiced it, if you've never flexed those muscles before, then you're probably going to come up blank. So it's good to put yourself in that spot, to force yourself to figure out what you would say. Now, in general, there's a few different ways this can go. So you see the interviewer sees that you've worked on a specific project. You mention it in your resume or it's on your public GitHub. And they just say, hey, tell me about it. What did you do on project X? I see you made this game. Tell me all about it. On the other hand, if you mention that you had a team project or something, they would try and narrow down, what did you specifically do for that team project? What role did you play? And there's many different roles. Sometimes you're more of an assistant, sometimes you're the technical lead, sometimes you're going along writing documentation and unit tests rather than the core development code. Ideally, nowadays, most software engineers wear most of the hats to get that practice, to keep their full skill set sharp. But it is possible to specialize. They might also be asking about sort of specific tools, languages, environments, frameworks that they use in their shop. And they want to get a sense of, have you done it before? Have you used those tools and projects before? So for instance, if you're applying for a Ruby job or a JavaScript job, they might say, hey, okay, so we use Ruby here. What's your experience with that language? Or what's your experience with this popular web framework? Or some other question, some variant of that idea. It's fine to say that you haven't used those languages or those tools, but at the same time, if you're applying for a JavaScript position and you've never used JavaScript before, you better have a good answer for why. Maybe you think that it can be done in other languages, or you think the experience will transfer. Much better is to just have had the experience in advance. Now, it's much better to be able to talk about your side projects than a school project. Now, personally, I attribute most of my success in undergrad to the privileges I had growing up, having a father who did computer science, coming from a background where a household where I could spend a lot of my free time on the computer. Besides that, I also worked on a lot of side projects, which again comes from the privilege of having a lot of free time. So during undergraduate, I was able to work on a lot of things that weren't just my schoolwork. Now, this was time consuming. It wasn't necessarily the most fun, although I had a good time with it, but it put me way ahead of my peers very quickly. It turns out a lot of learning to code, a lot of learning to program is just the sheer number of hours and the sheer number of new lines of code and new problems that you've tried to solve. It also gave me a very nice portfolio to show off if I ever needed to express my credentials. I had websites and I had pictures of desktop applications and code bases. GitHub wasn't as big a thing back then, but I would have been able to put all of my code into a GitHub. Would have been relatively easy to parlay that into a job. Now, I'll be honest, if you look back at these projects, most of them were actually pretty stupid and embarrassing. I mean, they were small things like video games and a website where you could sort your friends into different Harry Potter Hogwarts houses and stuff like that. And they're not necessarily the things that I want to talk about now that I'm a professor, but they were real projects I put time and effort into, and they made me a better programmer. And more importantly, they were things that I did, that only I had done before. So they were unique to me and demonstrated the skills that I could use. If you have the time this summer, and I know not everyone does, but if you have the time, one of the biggest things I can recommend is find a project you can work on that you will be excited to work on. Motivation is your biggest enemy here. Find something you want to put hours into and spend some time over the summer working on that. If you can put in the time, it's going to make a huge difference. And you end up with something that you can show off, even if it's just a stupid demo of a cooler idea. Even if it doesn't work half the time, no one's going to go through it and harass you about like details. But they can look at the source code, they can get a sense of what you do as a programmer when left to your own devices. And it's a huge thing for your resume. So if you can, get a software project, work on it over the summer, put it on your GitHub, and hey, if you make something cool, email me, share it with me. I would like to check it out. May not get back to you immediately, but I'll tell you, I do want to hear about it when my students are doing cool things in their free time. It makes a difference to me. So moving away from the project conversational interview, there's also a very interesting one called the critical thinking interview. Now, right now, I want you to once again pause the video and pick one of these questions to answer. So first one is, how many windows are there in New York City? How far is the sun from the earth? And how many ping pong balls fit in Smith Hall? Now, I don't want you to Google this. I don't want you to look this up. I want you to just pause the video and think and answer the question. Imagine you're sitting in an interview room. You can't have access to your phone or Google or anything, but you have to figure out the answer. Now, when you come back, hopefully you actually tried this. I get varying responses when I do this in class. It's often very frustrating for students. They get very upset. And that's actually not what you're supposed to do. You're not supposed to have an emotional, angry response, although it's hard not to because they're impossible questions, right? Like, how can you know how many windows are in New York City? But they're designed to see how you think and how you handle a difficult or impossible situation. If you just give up, well, that's not very encouraging for when you get tough questions in computer science, in coding situations, because sometimes there are no answers and sometimes there are. And there's a lot of different good strategies for handling these. Trying to just estimate the question as best you can, asking more questions to narrow down what the interviewer wants, making general assumptions that just say, hey, let's assume that a ping pong ball is 1 inch by 1 inch by 1 inch, and that Smith Hall is 10,000 feet by 10,000 feet by 10,000 feet. And you might be wildly wrong, but who cares? It's a dumb question anyway. Now, the good news is these kind of questions are becoming less and less common, because why wouldn't you just ask a coding or technical question? And in fact, Google's done some research that suggests this kind of question, which is almost more like trivia or, well, impossible, it doesn't actually measure anything important. There was no correlation in their studies between answering these questions and doing well in your job down the road. And that should probably make sense, right? I mean, if you are good at figuring out the number of ping pong balls in a building, well, how is that going to translate into solving questions involving hash maps and, web frameworks? Now, it does say something if you respond to this by getting aggressive and angry with the interviewer, which I've seen students do. They start getting a little frustrated with me. You definitely don't want to do that if it comes up. You be polite and respectful, and you deal with it the best you can. But personally, if I was giving an interview, I wouldn't use this technique. I don't think it has any merit. Brings me to the third kind, project architecture. So this is a little related to the first one, but slightly distinct. The idea is it's going to have you have more open-ended kinds of design, and there's not a right or wrong answer to this kind of thing. They're interested in your process, how you go about designing software. This is drawing on skills from your 275 class, your 475 class, where you had to go and make a large software project without really any starting code. And there's various ways you can answer this. Architecture diagrams, class diagrams, UML, but often they come in the form of diagrams, something that you can answer on a whiteboard, just mocking out like, classes or pieces of the system, relating the database to the front end, to the back end. There's many different kinds of structures for how to answer this kind of question. These will often be in the form of designing a new thing. So design the ultimate remote control. That'd be more of a hardware kind of project. But they also can be very different in sense of thinking about how you work with an existing one. How do you test a vending machine? What's your process? And in there, it's less of designing a thing and more about designing the process of how you go about testing something. An assignment I've used in class was Tinder for houses. So finding people who want to sell houses and matching them with people who want to buy houses, which I'm sure is a much more complicated problem in real life. But in terms of coding an app for it, starting to think about, what are the pieces you need, what sort of data structures you have, the database model can be very interesting. And as another example, I've also often suggested Facebook for dogs. So whatever the heck that would look like. But the idea here is they give you a very open-ended design problem, and you give your thoughts on how you'd actually go about coding it. This is more common for higher up positions, right? A architecture, a senior software engineer, you don't necessarily start off with this your first coding job, but it does come up, and it's in some ways I think it's a very fascinating exercise worth doing, particularly if you're going to have your own side projects. Now, of course, the biggest and most important one is whiteboard interviews. And this is one of the more popular, one of the more common. It's very likely that you will have a whiteboard interview when you go for your first job interview. So let me break down what a whiteboard interview typically looks like. They're going to give you a problem and they want you to code a solution. Now, that doesn't necessarily mean that you're going to be writing syntactically valid code that you run and unit test. It often historically has meant no IDE. And in fact, the classic whiteboard interview, you're just on a whiteboard in person, two people sitting in a room while you're standing at the whiteboard answering the coding question to the best of your ability. It's become increasingly common, particularly with the current pandemic, to have a phone interview or an over-the-internet interview, and you'll have a shared Google Doc or some other online website lets you share some amount of code. But it doesn't necessarily mean an IDE, although it can, right? Like this is not uncommon either to have a shared programming environment where you can run code, get autocomplete, get syntax highlighting. It varies a lot depending on the company, and to some extent it's different strategies. Now, they'll often allow you to choose your own language, Java, C++, Python, JavaScript. They sometimes even just say, pseudocode is fine. It doesn't have to compile, particularly if you're on a whiteboard. They're just trying to get a sense of how well you can think about it. And they'll expect that you could just fill in the details with a proper coding environment. Now, what kind of coding problems might they ask you? It can be a huge range. A classic one I've done is just reversing a string, and that's a very basic kind of question. There's a term of art called a fizzbuzz, where you have to code this particular program that's known as fizzbuzz. It involves you printing out those words at certain times, and it's meant to be trivially easy, something that any graduate of a computer science program should be able to do. Similarly, reversing a string is often put in that same branch. They just expect you to be able to do it without too much issue. Hopefully, these don't seem like very complicated concepts once you look into them, but if you haven't programmed for a while, if you haven't programmed a certain language, it can be surprisingly tricky. Other common ideas, given an array of data, remove any duplicates. And they'll be very vague with if it's an array or a list or a vector or some other kind of data structure. They'll give you just very little starting information and just tell you, oh, remove duplicates. They don't tell you if it's integers or strings or what. Another common problem, kind of classic, perhaps too overdone to actually see anymore, is sorting algorithms, right? So they'll ask you to code merge sort or something up on the whiteboard. I honestly don't think this shows up as much anymore because it's such a cliche, but it is still a valid question they could ask you. We talked about the knapsack problem earlier in the semester, which is conceivably a thing they could ask you to code. And that's a fairly complicated problem, as we're going to see with some of the other things going on in the course right now, NP hard stuff. So it'd be a bit of a surprising one, but that doesn't mean that you give up on it, right? Just because they ask you a computationally difficult question doesn't mean you shouldn't attempt to provide some kind of solution. We solve hard problems in computer science all the time, even if they're not optimally solved. I think a really interesting one here is this Morse code string has its spaces removed. And you may recall this is essentially the fourth project that I gave you. Now, I got this project from a post I read on Hacker News. Someone said that they gave it as a real job interview question. They actually had the candidate come in and code on a whiteboard what you guys did for Project 4. Personally, I couldn't imagine answering that in a job interview situation. I suppose I'd come up with something. I mean, I coded the project myself, but it would still be very difficult. I thought it made for a fantastic project for a course, but at the end of the day, these problems can be incredibly difficult. They don't really actually have a bound on them necessarily. So it can be quite interesting to see the range. And again, as I said, that difficulty range can be huge. You don't really know walking in what they're going to ask you. Might just be a trivial, easy question, and then you're over-prepared for nothing. Now, going back to the pragmatics of the whiteboard interview scenario, there's a few things I want to try and keep you in your mind. One of most of which is that it's not necessarily about getting the right answer. They want to try and figure out your thought process, how you approach coding problems. Now, there's a lot of things you can do in order to improve your answer. And one of the first most important things is to ask clarifying questions. They're going to be vague with their initial question, and this is supposed to be a conversation, a two-way street, if you will. So when you ask clarifying questions, you can find out more details that can help you answer the problem more effectively. Sometimes they're even going to spill, sort of hints along the way. But at the very least, you can't answer a question if you don't understand it. You can't solve a problem if you don't understand it. So asking, hey, does this have to work on empty strings? What if the array has non-integers like floats in it? Do I have to be able to sort things that are not comparable? There's a whole lot of potential questions you might need to ask along the way in order to answer it. So your first thought isn't to write code, it's to ask clarifying questions. Along the way, you also want to verbalize your thoughts. One of the worst things you can do is to go silent, to go quiet and not talk out loud and explain to the interviewer what you're doing, what you're trying. It's dead space, it's dead time during which the interviewer is filling their thoughts with goodness knows what. You would like to control the audio of the room, really. It doesn't mean raise your voice, it just means keep talking and saying what you're thinking out loud. Ideally, a good interviewer is going to talk you through things, and they're going to help you out if you're really struggling, if you just can't get one piece of it. They'll usually get you to the finish line, but they're doing sort of some mental calculation about how much help you needed and what that says about you as a programmer. And I'm not going to say that you never take the help, you never need the help. Sometimes it's very helpful, right? Help is helpful. But at the same time, it's a question of making sure that you can demonstrate that you're also able to think and respond. There's benefits to being able to receive help. That's a good skill in and of itself. So it's not the end of the world when they have to tell you part of the answer. It just means that you need to take their answer and use it to its utmost. Use it as effectively as you can. Now, when you're talking, it's not enough just to be using casual words. You want to communicate technically. You want to use the vocabulary that you've learned in this class about data structures and algorithms, big O and hash map and linear time algorithm, or over here we're going to need to do a swap. Use words that other programmers, other software engineers will recognize and respond to. There's a word of shibboleth that means that you're using terms that other people in your community will recognize as being core to that community. If you can pass the shibboleth that people put for you, they're more likely to recognize you as a peer and not just someone off the street. Now, it's hard to develop that vocabulary, but it happens organically over your lifetime of programming and communicating with other software engineers. It's why it's important that even when you're working with your classmates, even when you're working with in office hours, that you use the right vocabulary, that you start building up that vocabulary, that base of words over time and incrementally. Now, finally, a very important strategy here is when you are approaching the problem, your first goal is to get a correct and understandable algorithm. Not to try and be fancy, not to try and get something efficient. Your goal is just to answer the question they put in front of you. Because at the end of the day, that's what your boss actually cares about, is that you solve the problem. Ideally, you write it in such a way that you can explain it, that they understand it, that it seems like, yes, I wouldn't mind having to go back later and debug that code. And in fact, you might go through the code itself to make sure it's understandable. From there, the interviewer will often prompt you to find a more efficient solution. But I wouldn't recommend starting off with it. I would go with the simplest solution that works. Then, if you can think of ways to improve it, walk them through those improvements. And that can be a very impressive thing to do. Not only does it drag out the interview, but it makes you look smarter. It makes you seem like you know how to solve problems and make them more efficient. And in general, this is true for coding a project. Don't begin with the most complicated, fancy, fast solution. Because first of all, you have no idea if it's fast. If you don't actually profile your code, then you have no idea what's slowing it down. So it's important that you begin by getting it working and then do timing tests to figure out what the slow parts are and figure out how you can speed it up. And this is where you draw upon your algorithms and your data structure knowledge to realize, if I use a stack instead of a list, I can make this much more efficient, most likely. Then you make the change, you profile your code and find out it runs faster or it doesn't. Sometimes things are confusing about architectures or about a specific language or the way that some other code is implemented, and you realize afterwards that it's more complicated than you originally thought. It's the same case with these whiteboarding interviews. You don't start with the efficient solution, you start with the easy solution. Now, in terms of actually trying to solve the problem, actually trying to figure out what is the solution to this thing, there's a few tricks I can offer. Even though this is the sort of thing where the problems vary greatly, there are some common strategies. One of the biggest is what data structure, right? Anytime you're trying to solve a problem, one of the first questions you can ask is, what data structure am I building around? Which ones do I need? Pull out the common favorites for interview problems. Dictionaries, super common. As Jimmy said, hash maps are the answer to everything. Odds are good someone's going to pull out a hash map question. Queues, stacks, heaps, weirder ones, those come up too, right? Don't neglect them. Trees, super useful. Self-balancing binary search trees, tremendously useful. Very frequently, they're the answer to a lot of efficiency questions. But of course, sometimes, good old-fashioned array or a list, if that works, heck, go with it. Don't make it super complicated until you need it to be complicated. If you can get away with just saying, I'll just make an array and slap all the data into it, great, go with that. You might need more than one. You might not just have one array, you might need 5 arrays. You might say, I need a different array for each one of these characters in the string, so I'll have an array of arrays, right? There's many different complications that can happen here. But don't get caught up with the syntax. Don't get caught up in, I need a hash map, let me go code a hash map, right? Assume that you have it, unless they tell you that you need to code it, which, God goodness, at that point, what are they even doing? But if they are just asking you to solve the problem, don't try and figure out how to solve these other problems. Assume, until told otherwise, that you've got a sorting method, that you've got a hash map. Real programmers don't make their own sorting. And that actually brings up a good idea here of what algorithms can you leverage, right? So we've talked about a few different ideas this semester. Sorting is almost always a way to take a quadratic time problem and turn it into a linear rhythmic problem, an n log n. Hashing is often a strategy for taking a linear time problem or even a logarithmic time problem and making it average time constant. Now that's a fabulous tool, right, when we can use hashing. And if you can pull out a hash map, that solves a lot of efficiency issues. If you've got a graph problem, breadth first search, depth first search, Dijkstra's, prims, often the core of a lot of graph problems. Not all problems that are graphs that are involving sorting end up requiring the use of these algorithms, but they can be very powerful. And they're free, right? Like they're in your toolkit. You can just say, I'll just do a breadth first search. They probably won't ask you to code it. They'll just assume that you know how that works and that you could find a solution online. Now, the last one you can do is to also apply the techniques we've learned. And these are at a higher level. So we talked about things like reduction, right? From the NP-hard, where you take a existing solution to a different problem, transform your current problem to match that one, and reuse that existing solution. If you can turn it into a sorting problem, you can reuse sort, right? That's really helpful. Similarly, sort of idea is approximation. If someone gives you an NP-hard problem, you don't just shut down and give up. You say, okay, well, I can at least get a pretty good semi-accurate solution. And maybe they want you to code the brute force solution that actually finds 100% of the time the correct answer. But a lot of the time, they're happy just to say, yeah, this works for almost every case, the average case, the expected case. It fails on some of the worst possible cases, but how often do you even see those in practice? So bringing out SAT solvers or other approximation techniques, local search, can be a great way to bypass a hard problem. Dynamic programming is a whole thing. I wish we had more time to spend on it this semester, but if you read more about it, you see that there's a whole set of common techniques where you build on smaller answers and avoid repeated subproblems, right? It's not just like divide and conquer where you're breaking it up into easier to handle pieces. You reuse existing solutions. So memoization, slap a cache on top of a function, bang, you've already got a working solution. There's a lot of other ideas that we've talked about, like backtracking, that you can pull out in a whiteboard interview scenario. And if you can use the terminology surrounding it, you'll really impress the interviewer. Now, once you have a solution, it's very likely they're going to ask you about its efficiency, to describe the runtime complexity of the answer, often in terms of big O of the worst case or the best case, the average case. They might They might ask about big theta or big omega, although that's a lot less common. It's more of a interesting theoretical idea than it is something that comes up in practice. But the big omega lower bound of the worst case is often very interesting to talk about. They often want to know, can you take your existing solution and make it better? How could you make it more efficient in terms of time or space? And they'll have you walk through almost like you're doing the problem all over again, trying to find that solution. They want to know sometimes, could you actually code the optimal solution? And one perspective on that is, are you able to? Is that technically a feasible thing? But also, can you take your algorithmic solution, the pseudocode, and transform it into a real code? So depending on how specific you've been so far, they want you to flesh out the details. And again, a thing we haven't talked a lot too much this semester is space complexity, but it's just as important as time, as are a lot of other factors like energy efficiency. But you can often articulate in terms of how much space. If you have an array the size of input, it's going to be order n in terms of space. And you use big O notation for that too. They will often also mix it up and change the requirements out from under you. So they say, okay, well, you sorted this list. Now, what if it was only integers? What if you knew it was only going to be integers in the range 0 to 100? And that might lead to a completely different algorithm. You can ask further clarifying questions. You verbalize your ideas out loud. You really go through the whole process all over again. So I've talked a lot about how whiteboard interviews work. I brought up that we were going to have one. I've compared it to some alternatives. But a question I haven't answered, and one that should really be on your mind, is whether this is actually effective, right? I mean, you're going to be going into industry and eventually making hiring decisions and going through the hiring process on the other side of the table. And I want you to think about whether this is a good practice. What makes it effective and what doesn't make it effective? So here I've got some tweets, and the top one here is by a guy named Max Howell, who wrote Homebrew. And if you use a Mac and you've done some software development, you should recognize what that project is. It's a super popular program, right? This thing is super famous. And here he is criticizing an interview he had with Google where they asked him to invert a binary tree on a whiteboard, and apparently, he couldn't do it for one reason or another. Maybe he just rejected the premise that they were asking him this question, and they rejected him because he couldn't do it. And at some level, that's almost surreal that they would do that, right? Like that this is happening because he's already established himself, right? He made Homebrew, and he's clearly a talented software engineer. So it's almost silly that we would try and ask to verify, can he code, the binary tree inversion? Because who even needs to do that? How often would you have to code a binary tree inversion versus just going on the internet and Googling, first of all, what the heck a binary tree inversion is? So it's a silly situation, and I think his frustration is palpable in the tweet. Now down here in this other section, we have a tweet by someone who runs a coding boot camp, and they point out they have to train their students how to go through whiteboard interviews because it's such an artificial skill. And I mean, there's a reason it doesn't look like any of the things we've done in your classes. It's because it's not what you're going to do when you actually get into industry. It's essentially a fake problem that only exists to get you through the door. I might compare it, though, to the kind of questions you get on your final exam in your introductory computer science course. They're nothing like the questions we ask real software engineers, but they are there to try and validate that you can do what you say, that you can code at the basic level. But they're completely artificial. So that raises the question, if there's these arguments against them, why should we even have them? Now, on the one hand, maybe they measure subtle things, right? We don't necessarily know what they do measure, and perhaps it's a subtle, hard to detect thing. Maybe they're just there because they make the interviewer feel smart, and that's important psychologically, but obviously just a negative thing. It's more of an argument for why not. But they do make you feel smart, right? You have the answer and you're asking the interviewee a question that they may not know, and that's a power imbalance. And some people thrive on that. Some people like having that. It could also be a hazing thing, right? I suffered, I had to go through this, so I must make you go through this. Almost a vengeance kind of thing, right? Where you say, I suffered, so you should have to suffer too. It'll make me feel better about my own suffering. really negative emotions, but these are things that sometimes motivate people. There are alternatives that you might choose to do instead. One of the ones that became popular, and I think is still being done fairly often, is a take-home test, where you actually take home the project and you work on it over some number of days. And I've heard horror stories where they find out afterwards that they hired someone to do their take-home test. We see that right now with the take-home tests as we moved online. Many students are hiring people, are having other people complete assignments for them. The cheating is rampant at some universities. I would like to think that none of you have cheated in this course, that none of you have asked other people to do work for you. But at the end of the day, I've got no real verification that that's the case, besides running code analysis similarity metrics and assessing through other means. At the same time, the other problem with this is if someone asks you to take home an interview and work on it over several days, they're not going to pay you, right? This is not a paid process. You've effectively just done some work for them for free. And that's not necessarily fair to the interviewer, the interviewee, who may have to do many of these job interviews for absolutely no gain. They've just wasted their own time. I've already mentioned actually coding during these interviews is also another strategy that in some ways can be better for some people. It can help you with the process, since you have the ability to get autocomplete, run the code, see the error messages, write your own unit tests. You can go through your usual debugging strategies, but those can just be more stressful for some people. The same problems that you have for whiteboard interviews where they put you on the spot can happen with the coding test. And it doesn't necessarily remove the hazing vengeance elements. Another strategy is just to stick to conversational interviews, where you just talk about code that they put up on their GitHub. But again, that can be faked, right? There's nothing actually guaranteeing that that's your code. And it doesn't really suss out how you solve a given problem. So they have issues too. Now, I want to talk about some specific recommendations I have for getting through the interview that are a little bit less technical in nature. First of all, dress professionally. And honestly, I am so unqualified to give advice here. I barely dress professionally for my university job, and that's not necessarily even one where you have to dress professionally. Now, that brings up the point that exactly how you need to dress does depend on the position you're going for. You got to get a sense of the company culture and figure out, is a suit appropriate or something more business casual? The business casual is lower bound, though, from my perspective. Dress pants, dress skirt, whichever you're going to go with, choose ones that are dressy. Dressy shoes, dressy shirt. I don't even know what some of these mean, but I know I have a bunch in my closet that I've had other people pick out for me. Long sleeve at least, make sure it's tucked in. Open collar, if you have a collar. Potentially no tie. If you're going to have the open collar, no tie. If you come in a suit, then yes, you do bring in the tie. But if it's just business casual, then you don't wear a tie. You probably want to cover tattoos. That can vary a little bit. Certain startups will see it as a benefit, but you don't necessarily want to roll those dark dice, right? Unless you're really trying to send a certain message, which I don't necessarily recommend in this area, you probably want to cover them, no matter how cool and computer sciencey they might be. Don't wear your piercings. Maybe only use the studs. Studs can look good. They can tie together a professional outfit. I have been told. I do not have piercings, and I do not understand how they work. If you're going to wear heels, maybe keep it down to 1 inch. Personally, at 5 inches, I start falling over. If you're going to color your nails, choose a nude color, something that's pretty subdued. So personally, I don't even know what that means, but I've been told that you should follow that advice, and it seemed very credible to me. Ideally, also meet the interviewers if you can in advance, and then dress one level up from that. Assume that you should be just a little bit more formal than they are. At the same time, you want to be understated, right? You don't want to be ostentatious and draw too much attention to yourself. And then as one last note that I have here from my friend is wear a V-neck instead of a round collar so they don't see the undershirt. I think that information is more appropriate for a guy. But hey, personally, I think all the gender divides on the clothing are a little bit funny and a little bit silly. But some people take this very seriously. My dad wore a suit to work as a programmer every single day. And I think he had some difficulty fitting into the corporate culture sometimes because everyone else would wear business casual, but he always looked very professional and very on point. There's something to be said for that strategy. Now, another important idea is how you communicate. When a team has poor communication, it's going to lead to poor software. There's a lot of different problems that can happen when you have poor communication that we can't really deal with anymore. The days of the closet coder, the person living in their basement just coding all the time, are more or less over. Even in this remote era where we are all going online, we still have Teams and we still have Zoom conversations. We're still working together because we can't solve problems at scale without doing that. If you have a programmer on your team who can write the best code in the world, but no one can read it and the coder can't explain it, there's just no communication ability, that code is useless. It's going to rot. It's going to become out of date, and it'll be difficult to maintain. It'll be difficult to update. It'll be tough to debug it, to figure out when something goes wrong. And now the team is dependent on that hacker. They can't fire them. That person might become awful. They might start abusing their position. They might get fired. They might get hit by a truck. You never know what's going to happen to that person. And being dependent on a single person, a single point of failure, is awful. Companies don't want to do this anymore. Often, better to just dump the code and start over from scratch when you have one of these situations. That's why communication, the ability to interact with the people and convey your ideas, is so critical. It's so important. If you can, you want to prevent any of those problems where you can't communicate effectively in the interview. You don't want to ever put yourself in a situation where they walk away thinking you don't know how to talk about things. An important element of this is vocal clarity. If you if you can't talk correctly, then you're not going to be understandable. Don't cover your mouth when you speak. I see it all the time. People during an interview cover their mouths. Even if you're on Zoom, even if you're doing this remotely and your mic can still pick you up, it's not a good idea. It covers part of your face and looks unusual, and it may make you feel better, but it's not a good strategy. Ideally, face the person you are talking to, not the ground. It can be hard to maintain eye contact, particularly in Zoom, but it is something that humans thrive on. We look at each other's eyes, and looking away from that can be disconcerting. Speak slowly and clearly. That can be difficult, particularly if English is not your first language. Slowing down can be helpful. It doesn't always, but it can be. Enunciate clearly and distinctly. Practicing this skill makes you better at it, right? You can have training on vocal lessons for this. Ideally, have confidence. Speak as if you know what you're saying. Don't try and leave it lingering. Don't try and guess too often. Don't make it sound like you're kind of making things up. Speak like you know what you're talking about, like you know this stuff. Fake it till you make it, right? And project, if you can, if you're sitting up straight, then you can use your full diaphragm to get all of your voice. That doesn't mean you need to shout. You're not trying to sound angry, but don't mumble. Don't mumble. Don't just be quiet. You want to try and use your full range of voice. Body language is really important too. Your posture, I have terrible posture, how you sit can really say something. It can put you at ease or at intense. Having a firm handshake, making sure the webbies touch. This is not as important as it used to be if we're all moving online, but still, if you're in person, having that firm handshake, making sure that you commit to it is a benefit. Don't try and yank off the other person's hand. Most people don't respond well to that. Lean forward a little while you're listening. It shows enthusiasm. And it's a small kind of micro improvement, but a lot of people tend to respond to it versus if you're laconically laying back, just sort of relaxed and not paying attention, people don't tend to respond well to that. Keep your hands above the board. Don't keep them under the desk. It's a little bit weird on a Zoom call. You don't necessarily need to be holding up your hands. You don't want to be running them through your hair on your face. It's not healthy, first of all. Doing the templed approach is one way. ideally go for something that's natural to you. But if you're in an interview in person, don't put them under the table. Don't put them in your pockets. Keep them on the table. Try and look normal if you can. If you start thinking about your hands, that will stop being possible, but do what you can. Comfortable eye contact, right? We already talked about eye contact being important, but don't stare into their soul. Don't look as if you're trying to find out their deepest, darkest secrets. People don't respond well to that either. Comfortable eye contact, friendly. Have a sparkle in your eye, whatever the heck that means, and occasionally look away. Don't maintain the eye contact like you're having a staring contest. Enthusiasm, optimism, high energy to some extent, although too high energy can backfire for some people, but definitely medium energy for sure. Not someone who's like, okay, yeah, I'm here to do my job interview, I guess. I guess you're going to ask me questions. Let's get it over with. Let's just do this. Try and be there. Try and be a little excited, like you're interested in this job, this position, that you're optimistic about it, that you feel like you earned it, that you deserve it. People pick up on this and they respond well to it. And for dog's sake, goodness, this is not important in the Zoom era, but it is important in real life. Please shower, deodorant, take care of those basic essentials. I don't want to go into it. I don't want to talk about it too much, but I want to remind you that's a thing to do. That is a surefire way to end an interview badly, is to walk in and just not smell very well. Your attitude is important. Being friendly, that's really, really beneficial. If you can convey that attitude where they walk in and be like, oh, this guy's nice. This girl's friendly. I like this. Be positive. Don't be down about things. Try to keep things upbeat if you can. Positive attitudes beget positive attitudes. You want to put the interview in the best mood possible. That doesn't mean you should be cloying. That's the sickeningly sweet sensation. Too much sugar. Someone who's saccharine, who feels fake with how sugary they are, or feels just aggressively happy and sweet. Doesn't even have to be fake. It can be too much. You don't want that. It's not going to endear you to the interviewer. And at the same time, don't be too intense. Right? You gotta reel it in a little bit. You don't want to freak them out with your energy. I've seen people walk in and they're just all over the place, and you just want them to calm down. Don't be afraid every now and then. Take a deep breath. Try not to let it shudder like that. And be intense, be interested, but not too intense. There's a fine line for all of these things, and it's so difficult to capture it. It's so difficult to articulate what kind of behavior you want to do. Watching other people really helps. Watching yourself in a recording can really help. Practicing in front of a mirror, going through this multiple times, the more you do it, the better you get. The best actors get stage fright. This is what my acting coach told me when I was in high school, was the best actors get stage fright. They just get over it. It's not a big deal if you're nervous and everything. That's okay. But the more you work at it, the more you practice, the more you're able to manage those feelings of nervousness, that anxiety. Now, I'm trying to be practical here, so I want to talk about the realities of the interview. Here's a scenario for you. You're a software engineer. You've already got the job. You're now several years in, you're 25, say, and you're busy, right? Like you've got a job to do now. You're working very long hours trying to get the product out to the customers. And you need to hire some new people. So a new position opens up and your boss wants you to do the hiring. This is going to be tough because there's hundreds of applicants submitting from all over the place, all over the world now. It's remote, and they're all wildly different levels of quality. It's really tough to figure out who's good and who's not. And then someone says, hey, that position you just got, you should hire Miss Awesome, this person I know about. You should hire them. And you trust this person, you know them, maybe you went to school together, maybe they're a coworker, maybe a former boss, who knows, but they recommend them. Suddenly, the hiring task just got a lot simpler. That's good for you. You get to return to work much faster. One resume, one interview, you verify that the other person you trusted was right, you're done. Fantastic for you. You can get actual work done today. Even better, if you already know Miss Awesome and you're like, oh, of course, yes, I should definitely hire Miss Awesome. I didn't know she was applying. Great, narrowed down hundreds of applicants to just one instantly. The reality of the job hunt is that it's not what you know, it's who you know. That matters a lot more most of the time. Therefore, you need to network. And in fact, I'm going to say that's so important, I'm going to say it twice, is you really need to network. You need to establish these people who you know, who you can reach out to ask for suggestions on where to get a job, or to get recommendations, or to get ideas on how to improve yourself. Networking is so critical. In fact, I want to say it a third time. Networking is just one of the best ways to get a job. Most of the jobs I got prior to my first one were done via networking. Right? Well, okay, the only job I got prior to my first one was networking. But most jobs I know that people get come from having known someone else. It's less common in our industry because we have such a great skill set and we're so in demand, but it's still critically important, which is why I want to say again, networking is super important. And I don't know that I can even actually say this word enough. Networking is really at the heart of most job searches. So you really need to make sure, and in fact, I got to keep saying it, you got to network. And just to mix up a little bit, I want to mention you're going to have to network. So when it comes to networking, it's not like there is a rule book on how to do it. There's no algorithmic process. But here are some strategies. First of all, be a naturally charming and engaging person. Just be someone that other people want to know. It's a great strategy. Also, if you can, it really helps to be attractive and intelligent. You don't want to just be attractive or just be intelligent. You really want to be both. Some people try to go for one or the other, but it works much better when you are both. And you have to be generally attractive, right? Not just specifically attractive, but most people need to find you attractive. And you really want to be intelligent in all categories, in all fields, all disciplines. Know as much as you can. It doesn't hurt to be related to people who are good at networking. So this has been very beneficial. I have relatives who have good job contacts, and that's been very helpful for me, is just being related to people who are good at networking. That's not helpful, and it's super frustrating to hear because those are largely just things about who you are, right? You don't suddenly become intelligent overnight. You build it up over your life. You don't suddenly become attractive. You work at it. You get lucky. You roll some genetic die. There's so many things that are not under your control that factor into networking. That's really frustrating. So here are some things that you might actually be able to do. First of all, you can be an interesting person. Have projects, things that you do outside of class, outside of work. Have hobbies, things that make you different. Maybe you like gardening. Maybe you want to go rock climbing. Maybe you do things that put you out in public with other people. If you have interactions, if you have socializations with other people, not only are you going to get better at socializing, at being engaging, but you'll have more stories to tell. You'll have more experiences to draw upon, to connect with other people. And this makes you a more interesting person. Interesting people do interesting things, and it's the interesting things that make them an interesting person, right? It also helps putting yourself in situations where you're going to get to know people. If you don't interact with others, then how are you going to build up that network? There's never an opportunity to have the network. Internships, undergraduate research, hackathons, clubs. It's so difficult right now. This is such an impediment to your future career prospects. The conversations you're having with classmates right now, when you go to Spanish club or chocolate club, or when you go and play board games with some of your dorm mates, these build up your network, and they do it chaotically. They do it almost at random, but each one of these, you never know if they're going to be a potential future coworker who recommended you for a position. So the more of these you can get yourself into, these situations, the better. Now that doesn't mean that you need to force social interactions. People hate that. It's not a good thing. But that also means that when you go to these social situations, you're not just passively sitting there. Don't just show up to a club and then never talk. Interact with each other. Make sure you're having a good time. Make it be authentic, like you actually want to be there. And forge those connections with people that you want to forge connections with. Getting a recommendation from someone that you couldn't imagine working with isn't actually that helpful if you just end up having to work with them, right? Ideally, the more you can make this authentic, the better. This is hard. It's a delicate game, really, and it takes years to develop skills in it. I did not know really how to interact with people when I was younger. It took me a long time and a lot of practice, a lot of interaction, and I did it by observing, I did it by making a fool of myself a lot, and I still do, right? I make a fool of myself all the time. It's one of the best ways to teach and the best ways to learn, but it makes me better at interacting with people. Now, there's been a lot of advice, and again, you have to take all of it with a grain of salt because I've never had a real job. I've never been in industry. At some level, I don't know what I'm talking about. There's a lot of people online who can help you. There's a lot of people who you've interacted with who have gotten internships, who have gotten jobs, and you should get advice from all of them. I also want to make a plug for a book called Cracking the Coding Interview. And I'll tell you, I'm not being paid for this at all, but my wife and I, we both have our own copy of this book. It's so excellent. This is actually her copy because mine's stuck in the office. It looks very thick and heavy, but it's actually not that bad. It has lots of practice problems inside of it. In fact, the first maybe quarter, maybe even less of the book are all just, sort of introduction to computer science, a review of most of what we talked about this semester, and practice problems, with the remainder being the actual solutions to those problems. So this may seem intimidating, but it's actually not that bad. You should also just look at other services. University of Delaware has career services where they'll let you practice your interviewing, they'll go over your resume, they'll help you find internships, they'll help you network, they'll help you with learning how to negotiate. They're willing to go out there and help you with a lot of things. Ultimately, though, no one's going to just hand you a job. This doesn't just happen. You have to develop your skill set in computer science, but you also have to figure out how to do all the dispositionals, all the other interaction skills, the communication skills, the process-oriented skills, and you have to eventually go out there and put in the work, put in the time to find jobs. And it's not going to be easy. I mean, honestly, you guys have a raw deal ahead of you potentially. The economy is not shaping up to be the way it was even just a few years ago. And this move to remote is putting everything in flux, hiring freezes. It's a difficult world right now if you are getting close to graduation. And I wish I had more advice. I wish I had more experience to draw upon. No one has experience in what the world's going to look like. And I have even less experience with what the job industry looks like. But you're all smart, and you can get better at this stuff. You can stack the deck in your favor as much as possible. So that's pretty much my advice about all this. I wish you the best of luck on the final exam, and I look forward to talking to each one of you individually during your interview. Best of luck.